Page 21. We're going to talk about volume. Okay, so volume is the 3D space inside of something. Or like, if you were filling something up with water, that's volume. Talk about it in science class a lot. Yeah. So similar to surface area, when we're looking at prisms, we have basically two types of prisms. We have rectangular prisms and we have all other prisms. The reason why they're kind of separate is because with the rectangular prism, you have 6 different sides that could be considered the base of the rectangle. So like those 2 sides could be the base, or these 2 sides could be the base, or the top and the bottom could be the base, because they're all the same. With other prisms, that's not the case. The base has to be whatever polygon we have involved that's not a rectangle. So trapezoid or triangle, whatever. So we have some different formulas. Rectangular prism, volume is really easy. It's just length times width times height. That's it. And it doesn't matter which one's which. It's just we've got these 3 numbers. Volume is those 3 numbers multiplied together. So 672, 3672. Okay, and so this would be measured in centimeters cubed. We use cube units for 3-dimensional shapes. If you ever get mulch or work for a mulching company, they measure mulch in cubic feet because they're putting it down on your lawn. It's got to take up space. That's really it. Okay, do numbers 2 and 3. Ready, set, go. How fast can you do it? Nice. So really fast. Okay, so for number 2, length times width times height, 4.5 times 14 times 10. What does that equal? 630 cubic inches. And for this one, it's 8 times 12 times 39. What does that equal? 3,744 cubic feet. Okay. Easy, right? Good. It's a little more complicated for other prisms, but it's not that bad. It's a very simple formula. Surface area is definitely harder than volume, so this should be a lot easier. For all other prisms, this also works for rectangular prisms, but it's the capital B times H. Capital B still means the area of the base, which means like the area of the triangle or the trapezoid or whatever you have, and H is the height between the bases, same as before. So for number 4 here, what is the base of this prism? The triangle. Okay. So we have this triangle here on the bottom. So that triangle looks like this when wait. Or is it on the bottom, or is it? Oh, that's a weird. Yeah, it is on the bottom. Okay, I see it now. It's kind of tricky. There's the bottom one, there's the top one. So that triangle looks like this. To find the area, we need to do 1/2 base times height. Remember, a triangle has how many bases? No. Triangle has 3 bases. How many heights does a triangle have? 3. We need to use a base and a height that go together, that intersect. So 9, 10, 12 could all be the bases. Which one should we use? We should use 12. Why? Yes. We have the height that intersects the 12. Those are the ones we want to use. If we wanted to use 9 as the base, we would need to know this height right here that intersects the 9. If we wanted to use 10, maybe orange is not the best color, we would have to use this height right here that intersects the 10. So we have to use the ones that intersect. Okay, so the area of the triangle is 43.8. That's our capital B. And then times the height between the bases. What is the height between the bases? What is it? 5, yes. Height between the bases. So it's just area of the base times the height. 43.8 times 5. 219. Questions on that? Okay, number 5. What's the base of this prism? Triangle. Okay. You guys do number 5. Okay, to find the area of the base, what formula do we use?
25 times height times base.
Yes. Okay, so we're looking at a triangle, 1/2 base times height, or 0.5 times height times base, same thing. Okay, again, we got 3 bases to this triangle. Which one are we going to use? 11. Because the height, 5.4, is the one that intersects 11. Okay, so what did you guys get for the area of the base? 29.7. Okay, and then, so it's area of the base times the heights for the volume. Which height are we going to use now? 16. So that's the height between the bases, 16. So 29.7 times 16. Millimeters cubed. Okay, same thing for number 6. Area of the base times the height. What kind of base do we have? Trapezoid. Okay, do number 6. Okay, let's check. So area of the base times the height. The base is a trapezoid, so we're going to use the trapezoid area formula. So when we're looking at the trapezoid, what am I going to use for h? What? Morning. What's the height of the trapezoid? Jackson. 17.9. Okay. That's the height of the trapezoid. And then what are the two bases of the trapezoid? 36 and 14. Okay, so that's our area of the trapezoid. I got 447.5. Did you guys get that? The trapezoid? Okay. So that's the area of the base. That's this. And then times the height between the bases, which is 25. Yes. Height between the bases, 25. Okay. So we do 447.5 times 25. It's a pretty big number. Did you guys get that? Meters cubed. 11,187.5 meters cubed. Nice. Questions? All right. Let's go to the next page. I'll leave those as extra examples. Let's look at the cylinder. Okay, so for a cylinder, the volume is pi r squared times h. Notice that pi r squared, that's the formula for area of what? Circle. Yeah. So that's the area of the base times the height. This is actually the same formula as the one that we were just using, just special for circles. So pi r squared h, we'll use 3.14 for pi. So for number 9 here, it's just 3.14 times r squared, that's 18 squared, times 15. So pretty straightforward. It is a big number. 15,260.4.
Do you want us, whenever it's pi, do you want us to do 3.14?
Probably. That's what's on the SOL, so I figure we'll just get used to that. If I was going to do this in terms of pi, I would just do 18 squared times 15, and then put pi on the end. So I would not multiply the 3.14 in there and then just put pi. So that's like a lot easier, in my opinion, to just do that because you're just writing it on the end. But we'll probably just do decimals because get you guys used to that. Okay, you guys do number 10. Okay, so pi r squared h, 3.14 times, what's r? 11 divided by 2. Yep. 5.5, 11 over 2. You don't want to work. Times 21. You guys get this? Projector is really trying my patience. Okay, I want us to look at this application, these application problems here, and just talk about them. So here we have a triangular prism, and it says a cylinder with a 2 centimeter diameter is drilled through a triangular prism shown on the left. Find the volume So it's like this cylinder was removed from the prism here. So we would need to find two volumes. We would need the volume of what and the volume of what?
So
Yeah, we need the volume of the cylinder, and we need the volume of the prism. And then what would I do once I had those two volumes? Yeah, we would subtract. Which one minus which one? Prism minus the cylinder. So volume of the prism minus volume of the cylinder. We don't have to do that one. You can do it if you want, but I just want to talk about the process. Volume of the prism minus the volume of the cylinder. Let's look at number 12. A diagram of Eric's pool is shown on the left. He plans to fill his pool to a depth of 4 feet with a garden hose that has an 80 feet cubed per hour flow rate. How many hours will it take to fill the pool? What would I need to find first? Okay, would I need to find the up to? Okay, yeah. Yes. Yeah, he's not filling it to the top, so this one's a little tricky. He's only filling it up to 4 feet. So it would be pi times 27 over 2 squared times 4. That would be the volume of the cylinder. Let's just go ahead and do that one. Oh, wait. Oops, hold on. Miscalculated. Okay, did you guys get this for the volume? What's that? Okay. Yeah, if you're typing 27 over 2 squared into the calculator, make sure you put it in parentheses. Otherwise, it'll just square the 2. Or just do 13.5. What's that? Oh, okay, so that's the volume. We're trying to find how many hours will it take to fill the pool. And the hose fills at a rate of 80 feet cubed per hour. Does anyone know what we would do with that 80?
You would read 2,289.6 because it's 6 divided by 80.
Yes.
That's about like 28.
Yeah. Yeah. It's going to take a while. Yeah, we would divide. Yep. In some of you guys are in chemistry, right? Yeah, this is like your unit conversion, your stoichiometry. Feet cubed times 1 hour over 80 feet cubed to cancel out the feet cubed. Remember that? You know what I'm talking about? If you're not in chemistry, you'll see next week. Don't worry. Okay. Let's go to pyramids and cones. All right. So pyramids and cones have the same formula for volume. It's 1/3 times the area of the base times the height. For cones are on the back of this page here. Notice it's 1/3 pi r squared times the height, but pi r squared is the area of the base. So really it's the same formula. So for number 1 here, we've got a rectangular base for this pyramid. So area of the base, we just do 10 times 11, and then times the height. What's the height? 16. And then times 1/3 or divided by 3. We could write 0.6 repeating if we want. We could also just write it as like 1760 over 3 inches cubed as a fraction. Either one would be fine. Could round it and say 0.67. Okay, you guys do number 2. Okay, we got another rectangle-based pyramid. So what numbers would we multiply to find the area of the base? 21 times 9. Okay. And then what's the height? 5. So it's just 1/3 times 21 times 9 times 5. Or 21 times 9 times 5 divided by 3. You guys get 315?
Yes.
Nice. Okay. For number 3, we are missing something that we need. Find the volume. What are we missing? The heights of the pyramid. Okay. What are we going to use to find the height of the pyramid? Pythagorean theorem. Yeah. So just like we did with surface area, we've got that right triangle in there. What would the bottom side of that right triangle be? 7, right? Yeah, so we're going to use half that base. This one's also a triple, fun fact. So when we do the Pythagorean theorem, we should get 24 for the missing side. And then area of the base is just 14 squared. So it's 14 squared times 24. I keep forgetting to write the 1/3 there. Divided by 3. We get 1568. So just to remind you guys, like we're gonna keep using the Pythagorean theorem. We're gonna use it a lot. Let's go to the next page. Let's look at a cone or 2. So cones, like I mentioned, it really is 1/3 area of the base times the height. But since it's always going to be a circle for a cone, we can just do 1/3 times pi r squared times the height. So 1/3 times 3.14. In this case, times 9 squared times 17. We can just do that. Okay, in number 9, I want to point out that we would need to use Pythagorean theorem again here to find the height. We would do 22.5 squared minus 13.5 squared to get h. Very similar to what we did with the pyramid. Okay. We don't have to do that one. It's basically the same idea. Use Pythagorean theorem to find whatever you need, whether it's, for surface area, we needed slant height. For this, we need actual height. Okay, last but not least, let's go to, I think it's page 29. Yeah. Okay. So for a sphere, our formula is 4/3 pi r cubed. To do cubed on the graphing calculator, you can press math 3. I'll show you that in a sec. There we go. So if I was going to do 3.14 times 4/3 times 7. To do cubed, I can do the caret here and a 3 like that. I just don't like the way that that looks, so I like to press math right there under alpha. And then the third option down, so I can press the number 3. And it gives me like a little cubed. So that's math 3. It's an ugly fraction. I'll probably just go first. $1436.03. Oops. And for a hemisphere, it's just 2/3 pi r cubed. That's just a different. Okay. So that's volume. Questions on volume? Feeling pretty good? Usually a simpler formula than surface area. Okay. Yeah.